You know, every time you send an email, buy something online, or just scroll through your phone, your entire digital life is being protected by these invisible locks. And for decades, they've been pretty much unbreakable. But what if I told you a new kind of master key is being forged? One that threatens to unlock, well, every...
So here's our game plan. We're going to start with the encrypted world we're all living in right now. Then we'll dive into the quantum threat that's on the horizon. We'll look at why this is a problem today, not years from now, and then get into the really cool part, the new quantum-proof defenses being built and the global race to get them in place before it's too late.
All right, so first things first. To really get what's at stake, we need to understand the foundations of the digital fortress we all live in. How does it even work?
Well, at the heart of it all is this really clever idea called public key cryptography. The easiest way to think about it is like this. You have a special padlock that you can copy and give out to everyone. Anyone can use that padlock to lock a message in a box. But only you have the one-of-a-kind private key that can actually open it. It's the whole principle behind things like RSA encryption that keeps the internet running.
Now, the secret sauce here isn't a physical lock. It's a math problem. The challenge of figuring out your private key just by looking at your public padlock is so incredibly hard. We're talking math problems that would take our best supercomputers millions, even billions of years to solve. For all intents and purposes, it's been an impenetrable brick wall.
But what happens when a new kind of computer shows up? One that doesn't just play by the old rules, but completely rewrites the rule book. This, right here, is the quantum threat.
And let's be clear, a quantum computer isn't just a faster laptop. That's a huge misconception. These machines are a completely different kind of beast. They use the bizarre rules of quantum physics, like superposition and entanglement, to look at problems in a way that's totally alien to a regular computer. They don't just calculate faster, they think differently. And this is the weapon. Back in 1994, a mathematician named Peter Shor created an algorithm designed to run on one of these quantum computers. And it just so happens that this algorithm is the perfect skeleton key, specifically designed to solve the exact type of hard math problem that our entire digital security is built on.
The difference in how they attack the problem is just staggering. A normal supercomputer has to use brute force. It's like trying every single possible key on a keychain, one by one by one. But a quantum computer running Shor's algorithm, it's more like it can see the internal mechanics of the lock itself and just calculate the one true key almost instantly.
Let's put some numbers on this to really let it sink in. To break a standard key, the kind that protects your banking info right now, would take the fastest supercomputer we have today around 300 trillion years. That's not a real number. It's so much longer than the age of the known universe. It's functionally impossible.
But a powerful enough quantum computer, it could do the exact same job in under 8 hours. From 300 trillion years down to less than a workday. This one fact changes everything. It completely shatters the very foundation our secure digital world is built on.
Okay, so you might be thinking, all right, that's scary, but we don't have a quantum computer that powerful just yet. So what's the rush? Well, this is where it gets really chilling, because security experts are worried about a strategy that's happening right now.
It's a concept called harvest now, decrypt later. And the idea is as simple as it is terrifying. Bad actors, maybe even entire nations, don't need a quantum computer today. All they need is a really, really big hard drive.
Just think about it. Every encrypted file, every secret government memo, every financial transaction that crosses the internet today, it can all be intercepted, copied, and stored. They're building massive libraries of our most sensitive data, all of it currently safe behind today's encryption, just waiting for the day that quantum master key gets built.
So, you have to ask yourself what kind of information needs to stay secret for more than, say, 10 or 20 years.
Yeah, the list is basically everything important. We're talking about government and military secrets, corporate intellectual property, the blueprints for the next big thing, all of our financial records, and of course, our private health information and personal messages. Any data that has a long shelf life is a target.
Okay, so that's the doom and gloom. The good news?
The world's brightest minds in cryptography are not just sitting around waiting for this disaster. They are in an all-out race to forge a whole new generation of locks. Locks that are quantum-proof.
And this counteroffensive is moving along two major paths. On one hand, you have post-quantum cryptography, or PQC. Think of this as the software fix. On the other hand, you have quantum key distribution, or QKD, which is a hardware fix that uses the actual laws of physics as its defense.
So PQC is the most practical solution for widespread use, mainly because it's software-based. The whole idea is to find brand new types of math problems that are hard for all computers, even the quantum ones. Instead of factoring, we're talking about really complex stuff like lattice-based cryptography. The beauty is, these new algorithms are designed to be swapped into the systems we already have, upgrading our security from the inside.
Now, QKD, this is where things get really wild. This approach doesn't depend on a math problem being hard. It depends on a fundamental law of physics. The act of observing a quantum system changes it, period. So if you try to send a key using single particles of light, any eavesdropper who tries to intercept and measure that key will literally leave behind evidence. They'll create errors that you can detect immediately. It's like having a lock that screams, "I'm being picked," the instant a thief lays a finger on it. So with these solutions identified and being developed, the world is now in the middle of one of the biggest, most critical infrastructure upgrades in human history. The race is officially on to get these new defenses deployed everywhere.
And this isn't just an idea. This is real, and it's happening right now. The U.S. National Institute of Standards and Technology, NIST, has been running a global competition since 2016 to find the best new algorithms. They announced the first winners in 2022, and in 2024, the official standards are being published. The transition has begun.
You know, this entire fire drill has taught the security community a vital lesson, and it's led to this new guiding principle: crypto agility. The goal is to never again be caught flat-footed. We can't bet the entire farm on one unbreakable system. Instead, we have to build our infrastructure to be flexible, so that the next time a new threat comes along, we can just swap out the vulnerable part without having to rebuild the entire internet from scratch.
So, we're left with this enormous question. Our entire digital world was built on one kind of lock, and now we're in a race between the people building the quantum master key and the people building the new quantum-proof locks. Are we going to be able to upgrade everything in time? It's one of the most important technological challenges of our lifetime, and frankly, the race is on.